Welcome to the Star Mother Kit, recording and video instructions for your Star Mother. It's called the Star Mother because literally when waves gather like this, they create the gravity, the collapse, the centering force, the implosion, which is the beginning of gravity and the mother of stars. This, we believe, is the only possible three-dimensional fractal, this 3D stellation interdigitation of the dodecahedron. You'll see more about this as we assemble our fun kit. These animations are courtesy of Implosion Group, soulinvitation.com. See how these 12 light cones, when they nest and converge, actually trace the path which allow an infinite nest of interdigitated dodecahedra, pentagonal dodecahedron, to nest and embed. Notice how this looks like a flame or a fire. We call this the time star. See how the waves converge and they make this implosion. Here's the platonics nesting. Now we're getting to our Star Mother Kit instructions. These are the instructions you received with your Star Mother, and we're going to guide you through the building process in this video with the help of Irina, who is from Perugia. So this is a piece of the icosahedron, what it looks like from the Star Mother. But we're going to start from the very beginning. Here's Irina. We're about to see her show you how to put together your Star Mother. The first part important is to understand the angle to put the green tetra sticks into the red zone tool rhombi icosa connector. Notice that there's a rectangular hole facing you, and at opposite ends of the rectangular hole, you be sure you put the green stick in at the correct angle. The angle needs to be right so it makes this spread. You see how it's actually pointing away from the other one. So the two green sticks are pointing away from each other to make this long angle to allow us to begin to build our square icosahedron. This is the way we find a path to use the rhombi icosa connector, which has the 1326 zones, to make a simple square. The simple square is going to be the beginning of our octahedron. So you've got this red connector. You're finding at the opposite ends of this square, see the opposite ends of this square, it's actually a sharper connection here. Here the two green sticks are in at an angle. See, yes, see the different angle for those green sticks at this end? So notice how we call this a square, but it's actually kind of a parallelogram. This is the hardest part of your whole kit. If you can get this, you can get the whole thing together. So see this angle of this green stick parallelogram. This is the important part. This is the beginning of your Star Mother. Now we're going to put a pyramid. See how these green sticks are at this angle? See how two of the green sticks are opposite to the square, and two of the other green sticks are opposite to the double triangle square. So these green sticks are now going to fit perfectly to nest on top of this parallelogram square to turn it into a four-sided pyramid. A four-sided pyramid is the top of an octahedron. This is half of an octahedron now. This is the beginning of your Star Mother. Now, opposite side to this, you just put one on exactly the same way. So just repeat what you just did and assemble the same four sticks the same way into the octahedron. Two of them are at opposite ends of a square, and the other two are further apart at opposite ends of the two triangles on the side of the square. This is a tough angle. Get this angle right so that you can finish assembling your octahedron. I'm helping Irina do this here. You want to be sure your connectors are firmly seated in there and the angle is right. Again, two of them are pointing from the opposite of a square and the other two are the opposite ends of triangles. This will allow your four green sticks now to fit on the other side of your half octahedra, completing the assembly of the octahedron. Oops, got that one in wrong. That's right, you can put it back together. It's best actually when you're assembling the zone tool connectors that you don't push the connections all the way in until you get the whole thing together. so that you just partially assemble it until all of them snaps together. We say this is like scenes from a marriage, where you first gradually line everything up, and then only when you're really ready do you snap it all together tightly. Fine, this is the diamond light body, the octahedra. Octa means 8, and hedra means faces or sides. So actually we have 8 faces, the octahedra, like a diamond. Next, we're going to take a triangle, actually a 3-sided pyramid, made of green sticks into a white connector. We're using a white connector now because these are going to be the vertices of the cube into the dodeca. So take a white connector and put 3 green sticks carefully facing. See how they kind of all rotate around? They're all rotating in the same direction. That's the critical image right there. See it? 3 green sticks all facing in the same direction around a triangle. And you're going to put one of these 3-sided pyramids onto every single face of this octahedron. So in a sense, you are stellating the octahedron now. You're putting a 3-sided pyramid onto every single face of this octahedron. First, we'll do the 4 of them that turn it into a tetrahedron. Oh, see, I'm telling Irina here, put this over here now. So first you're going to see a tetra. Yeah, see? We're picking the 4 of 8 faces of this octa to put this stellation, this 3-sided pyramid, onto. So we turn the octahedron into a larger tetrahedron with an octa at the center. So good. See, now I have 2 of these 3-sided pyramids onto my octahedron. And now I'm showing Irina where to put the other one to stellate the octa to finish making a big tetra out of this octa. Tetra means 4, so tetrahedron has 4 faces and 6 vertex. Irina's reaching for another triangle here, another 3-sided pyramid. Got to get the angle right. If you don't get these assembled right, they don't fit. Oops! Okay, so if you put your 3, there we go. If you put your 3 sticks in correctly, good, almost ready. See how we're building a big tetrahedron out of an octahedron? So good. We put 4 triangular pyramids onto opposite vertex of the octa, and we now have a large tetra with 4 white vertex tips. And now I put 4 more on, and this turns it into a star tetrahedron, the outer vertex of which are about to become a cube. And now we're going to play you some fun little animations. See if you took your 2 tetra, you'd see an octa in the center. Isn't that a nice little animation? And if you take your 2 tetra, you have a cube on the outside. And that's exactly what we're about to do here. We're going to put these outer vertex edges of the cube in place. We take the white vertex of the 2 interdigitated tetrahedron and we put a blue short stick across very carefully. You kind of have to pull it apart. Now we bend this blue stick just a little bit, and now it's good where if you really kind of loosen the connectors a little bit on this inner cube to make it, to make it go in a little easier. This is where it's easier if you actually loosen the connectors a little bit. Good. So now we've pushed the blue sticks in to complete our cube. So now we have a star tetrahedron with a red vertex octa in the center and a blue edged cube with 8 white vertex on the outside. This is star tetracube. This is sometimes called Metatron's cube. This is what the flower of life is really based on, this star tetracube. This next part is the most profound part of your Star Mother Kit assembly. We now are about to learn how to nest a cube into a dodecahedron. This is very profound because it's literally the 4th dimension. Take 5 short blue sticks and put them in around a pint into the yellow rhombi icosa. This yellow is about to become your icosa. Now you take 2 of the edges of this blue array. See how I take two that have one stick between them, and I get the right angle, and I push them into my cube. Now, I've got two edges of that 5-stick yellow 5-sided pyramid. Now here's the trick. On the adjacent one, I have 2 between, and on the right-hand side, I have 1 edge between. See how I have 2 of the blue sticks coming up, and then 1. Now notice, on the right, 2 blue sticks. On the top and bottom, 1 blue stick facing center. Here, 2 blue sticks facing center. So place your yellow 5-sided pyramids onto the cube this way, and presto bingo, see those places in the center that are now opened up? That's where the white sphere rhombicosa connector is going right there to place miraculously your white vertex dodeca around this cube. So get ready, we're going to put a white ball now in those inner space connections. So I show Irina where to put the white ball in. See now the white balls are in there? So we've got the dodecahedron nested around a cube. First we're going to play you some nice little movies here so you can see what it's like to put a cube around a dodecahedron. This is called the fourth dimension, the tesseract, the hypercube, because it's the only possible fourth superposed axis of spin symmetry to nest a cube in a dodecahedron. See, there's the cube in the dodeca, and that was the 32-degree tilt from the 612 to the 510 view. 612 view there, and 510 view, and that's the tilt, the chin angle of the Sphinx. And this is just another neat little film showing you how the cube nests in the dodecahedron. Inside there we have a red tetra, a yellow cube, and a white dodecahedron. So this is just giving you an idea of what you have nested so far in your Star Mother kit. So at this point in our Star Mother assembly, see that the white balls around the cube are all making a dodeca. So the cube white vertex are also part of a pentagonal dodecahedron. All the white balls right now, 5, 10, 15, 20, make the vertex of a pentagonal dodecahedron. Notice that the edges of this inner white vertex dodecahedron are actually implicit, not explicit. See how I've finished putting that white ball in there? So the white vertex of the cube are also white vertexes of the inner dodecahedron. They're pentagonal in their array. It's called a pentagonal dodeca. Do means 2, dec means 10. Dodec is 2 plus 10 or 12 face, and 2 times 10 or 20 vertex. So now the yellow rhombi-icosa connectors, the yellow spheres, are in icosa. The edge of the blue edged cube inside is 1.0. The edge of that right there, that dodeca, is 0.618, and the stellation straight out from the edge of the cube to the yellow icosa is also 1.0. So you have 0.618 and 1. You have 0.618 inside and 1.0 to the icosa. And now we're adding the 1.618 golden ratio medium blue stick connector between all of the yellow vertex to complete the edges of our icosahedron. Very simple. If you just put one end in and then bend it a bit as you slide in the other, it goes together more easily. Here is our beautiful icosahedron. Very simple. Icosa is the mirror or dual of the dodeca because it has the same number of faces as the dodeca has vertex, and vice versa. So the icosa has 12 vertex to match the 12 faces of the dodeca, and the icosa has 20 faces to match the 20 vertex of the dodeca. This is called a dual, an internal mirror. And what's neat is you see, you just extended the edges of the inner dodeca straight out to make the icosa, and now we're going to extend the edges of that icosa straight out to make another dodeca. And that's the point. This could go on forever We think it's the only possible truly three-dimensional fractal. So the way we now stellate this dodeca is what Irina is showing us right now. You take 3 of the long blue sticks. Let's focus here, focus. You put 3 of the long blue sticks, there we go. 3 of the long blue sticks just around one simple triangle in another white connector. We're using white connectors because we're making another dodeca, the same as the inner except it's outer. Very simple. So we put this 3-sided pyramid on each face of this icosahedron. This is called stellating, or extending straight out, again by golden ratio, every edge of this icosa. This edge is now 2.618. So we had 0.618 in the inner dodeca. We had 1.0 cube, 1.0 stellation of the dodeca. We had 1.618 edge length of that yellow icosa. And now we have 2.618, the edge of this stellation of the icosa into the bigger dodeca. And there it is! We've stellated our icosa into a big dodeca. You see? The outer white vertex are a giant dodecahedron. Dodecahedron outside, dodecahedron inside. This is called inside out or three-dimensionally fractal. And now we simply finish our job by putting another stick of that same length, the long blue stick, the 2.618, to complete the edges of this giant dodecahedron. And this is going to complete our exciting Star Mother assembly. This is profound because you see you could extend the edge of this dodeca out the same way to get on our icosa. Now if you visualize that these extensions were actually waves interfering constructively in 3 dimensions by golden mean ratio, you begin to see what happens to charge, waves of electric charge, in your own DNA. There, now here's the fully assembled Star Mother. See, inside you have the inside dodeca white, and then we stellate that by 1.0 to the yellow icosa. Yeah, I'm pointing to the green stellated, the interdigitated tetra in the center. There's the white dodeca. There we are. And now we stellated 1.0. Good. To icosa. 1.618 edge icosa. 2.618 stellation of the icosa. And 2.618 dodeca. So, in this array, every vertex, the x, y, and z coordinate of which would be only a whole number multiple of golden mean ratio, dodeca, icosa, dodeca, icosa, dodeca, icosa, forever. And this is a real three-dimensional fractal. Isn't it fun? Okay. Now, in the next section, we're going to ask you to visualize a path for charge as it's entering the dodeca. Remember this path. See those cones on the top and bottom? This path for charge compressing is reflected in how the dodecahedron traces the geometry in your DNA, and we're going to begin to introduce the concept of the grail as the compression path for charge down a caduceus into the charge fractal that's your DNA. Charge fractal means infinite non-destructive compression. This means a place where charge can be compressed. First, this lovely little animation. See the 2 tetra, the octa, the cube, and the dodeca, all in this spin path. We just play this Star Mother 3D animation one more time. Visualize like there's 12 cones, all 60-degree cones, converging on this center point. These 12 cones are making a compression happen non-destructively. This is the way biology works. This is called our dodeca soap bubble animation. Notice that the scale changes, the ratio does not. This is called scale invariance and is the key to non-destructive compression and three-dimensional fractality, or self-similarity, optimized by golden mean ratio. We also play you this little animation of the inside versus outside sphere radii of concentric dodecahedron spheres actually accurately maps the radius ratios of the orbital radius of Earth to Mars. So there's many parts of Kepler's dream that the orbital radii were actually based on the Platonic solids is really true. In this section, we're explaining that the Poincaré-Einstein symmetry array, the S3 group, is actually the stellation of the dodecahedron. So Self-similarity, we believe strongly, is actually the cause of gravity, because it's the symmetry which allows the infinite non-destructive collapse, which Einstein correctly modeled to be the source and mother of gravity. The mother of stars, get it? The star mother. Since the dodecahedron is based on golden mean ratio, and this is the purpose. Yes, the dodecahedron in DNA. We're playing here some of the original audio tracks from some of the early animations. This one is called DNA High-Res Spin. Notice the ratchet step function of the dodeca down the helical stairway of DNA. Notice that the short wave in DNA is nested, braided, or embedded. Short wave within long wave, this is called enveloping. And this is the mechanic by which the phonon geometry of emotion programs DNA. It's the coherence of this recursive braiding function that allows coherent emotion to actually program DNA by mechanically aligning the active sites. Notice that when you revolve the Grail cup, first you think you're outside, then you think you're inside, then you're inside out. You solved the problem of separateness. See, the swastika is in there also. See the hex morph as we tilt that dodecahedron from the hex to the pent view. It's the real key to the flower of life. And now we play a little animation that shows this energy cascade that's happening just like the side view down the nest of the dodeca-icosa, the caduceus flame, this implosion, this wormhole, this non-destructive compression, this creation of suction at center, gravity making, that happens in the EKG, similar to the dodeca-icosa interdigitation that is the Earth grid. That's the basis of your star mother. This animation is called the fractal zoom, as you'll see why in a minute. This is just another visual to see how the dodeca stellates and nests. It's important to understand that our DNA is so based on the golden mean ratio that allows it to do the non-destructive compression of charge. We think that actually non-destructive compression of charge is actually how emotion becomes shareable and how biology discovers how to make the coherence of the electric charge field called collective mind. This is Jodie Foster's dodeca vehicle in the movie Contact, based on actually Montauk. Do you see how infinite non-destructive compression works? You can get in here and ride non-destructively, jumping into the wormhole at the core center of your DNA, and zoom into a lucid dream. The adding and multiplying of the waves based on constructive golden ratio interference, adding and multiplying wavelength and wave velocity, creates that compression into the fractal. And in a fractal, you can zoom in forever, and that's the fun part. These animations are intended to be a bit psychoactive and psychokinetic. But imagine what you see at the moment of death, or better, a lucid dream in your own DNA. You're seeing the way biology has compressed charge to store an infinite well of survival information. But in here, the infinite form of coherence is fractal, and there only the shareable survive. What this means is, at the point of maximum compression, perfect fractality, only waves that perfectly lock into phase actually become able to propagate and share. So this is the profound, deep message here, that in the center of this perfect compression, the implosion, the suction to center, is what makes gravity, creates centering force and fusion. This is a deep understanding. See, soulinvitation.com/gravitycode. This is a discussion of the way in which perfect, non-destructive collapse actually solves the problems of physics. Thank you very much.
those days where it's a minute away from snowing. And there's this electricity in the air. You can almost hear it, right? And this bag was just dancing with me. Like a little kid begging me to play with it. For 15 minutes.
Simulated in a laboratory, a tornado is fairly simple to analyze. It's really a whirlpool of converging opposites. Upwelling warm air confronts down-tumbling cool. Dry air encounters moist. Winds aloft collide with winds below.
The golden ratio. Visually, there exists a graceful equilibrium between the shape's length and width. When it's squared, it leaves a smaller golden rectangle behind. The squaring can continue to infinity. Remember Da Vinci, artist, inventor, sculptor, naturalist, Italy, 15th century. Rediscovered the balanced perfection of the golden rectangle and penciled it into his masterpieces. Connecting a curve through the concentric golden rectangles, you generate the mythical golden spiral. Pythagoras loved this shape, for he found it everywhere in nature. The nautilus shell, ram's horns, whirlpools, tornadoes, our fingerprints, our DNA, and even our Milky Way.